All right, we're looking at section 5.2, and 5.2 covers the sum and difference formulas, and you're going to see, you're going to look at this and you're going to say, well, why in the world do I need this when I've got a calculator? I can just go ahead and punch it in. Guys, you're not always going to be literally doing the sine of 47 degrees or the sine of 15 degrees. There are situations where you're going to have the variables in there, and you're going to have to work with algebra. We're going to look at how to use this and how they work, but you're not always looking at, and we're going to actually find what the sine of 15 is when that's not one of the angles that we typically are going to have on the unit circle. We're going to use those unit circle values to get that angle's sine. But it's also just to expose you to it, let you see how it works, and give you a foundation to use it later if you need to. So don't always look at some of these things and say, okay, well, this is useless because the problems that they're showing I would never do. I just pick up a calculator. That's not the only use for it. Sometimes you just need something simple to get kind of comfortable with a formula. All right, so we're going to start off with the cosine of the difference of two angles. And all that is the cosine of the difference of two angles, alpha minus beta. So the cosine of alpha minus beta equals cosine alpha times cosine beta plus sine alpha sine beta. And that's all there is to it. You just plug in what you know, and this over here is going to be used to calculate what you're trying to find over here. So the best way to do this is just to do an example. So let's look at an example. Find the exact value of the cosine of 15 degrees. Now this is one of those situations where that's not a unit circle angle, so we wouldn't know that. So what you want to do is you're going to do cosine, not infinity, alpha minus beta, and we know that that is cosine alpha times cosine beta plus sine alpha sine beta. Now what we want to do is we want to choose two angles that are actually on the unit circle as alpha and beta that will subtract to give me this number right here. So I'm looking for cosine of 15 degrees. So let me write that down one. So cosine of 15 degrees, and I'm looking for two angles on the unit circle that I know. Now, the known angles on the unit circle, the pi over 6, pi over 4, pi over 3, all those. 30, 60, 90, 45. So you're looking for two of those angles that are going to subtract and give you 15. Hopefully you can recognize that pretty easy. You're looking for cosine of 45 degrees minus 30 degrees. And then all you do is you go over here and you fill in all this. So I know that alpha is 45, beta is 30. So all I do is go over here and I pull out all those values from the unit circle and plug them in. So when I do that, what is the cosine of 45? Well, that's the square root of 2 over 2 times the cosine of beta. Well, what's the cosine of 30? Well, that's the square root of 3 over 2. And plus the sine of 45, square root of 2 over 2, times the sine of 30, which is going to be 1/2. So then I'm going to multiply these. Square root of 2 times the square root of 3 gives me the square root of 6 over 4 plus the square root of 2 over 4. And I can put that together, and you want to write this as one term. So we end up with the square root of 6 plus the square root of 2 over 4. And that's the answer you're looking for. So here we find the exact value, not a decimal approximation, which a calculator is going to give you a decimal approximation, but there is the exact value for the cosine of 15 degrees. All right, now we know that the cosine of 30 degrees is the square root of 3 over 2. Let's obtain this exact value using cosine of 30 equals cosine of 90 minus 60 in the difference formula for cosines. All right, so all we're doing is we're verifying that we're going to get this. So the cosine of 30, but we're going to use that as the cosine of 90 degrees minus 60 degrees. So that means we're going to have cosine 90 degrees times cosine 60 degrees plus sine 90 degrees sine 60 degrees. Now the cosine of 90 degrees is 0. Cosine of 60 is going to be 1/2, even though it doesn't matter because it's times 0, so it's going away. Sine of 90 is 1, and the sine of 60 is the square root of 3 over 2. So we end up with the square root of 3 over 2, because that goes away to 0. So we did verify that the cosine of 30 degrees is the square root of 3 over 2. All right, and another way that you might see this is written like this. Find the exact value of cosine 80 times cosine 20 plus sine 80 sine 20. Well, the thing is, all you're doing here is you're working backwards. So we know that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. So here we've got alpha is 80 and cosine is beta, or 20 is beta. So all we're doing is we're working backwards, and we're finding that we're doing cosine of 80 minus 20, which is a cosine of 60, and that cosine of 60 is going to be 1/2. So you can also work backwards. And the reason we know that we want to work backwards is because I don't know what the cosine of 80 and 20 are, or the sine of 80 and 20. They're not those key values on the unit circle that I know. All right, and we can also use these equations to verify identities. So here we've got cosine alpha minus beta over sine alpha cosine beta, and cotangent alpha plus tangent beta is what we want it to show that it works for. So we're going to look for, our left side's more complicated. So we've got cosine alpha minus beta over sine alpha cosine beta. Those are multiplied. So that's technically one term. Remember, terms are separated by minuses and additions. So we're going to use the cosine, the difference formula for cosine on top, and we're going to get cosine alpha cosine beta minus sine alpha sine beta, and we're going to divide that by sine alpha cosine beta. Now remember, since we have a single term here, we can divide it into both parts. We're going to split it up. We need two terms because over here, look, we've got two terms. So that's kind of a clue which direction you want to go. You're taking a single term here, you're making it into two terms. So I'm going to move down here so I've got a little more room. You're going to have cosine alpha cosine beta divided by sine alpha cosine beta. minus sine alpha sine beta over sine alpha cosine beta. All right, and then you want to cancel out whatever will cancel out. So here I've got the cosine betas are common here. So I end up with cosine alpha over sine alpha, which guess what? That's cotangent alpha, so we're good there. And then over here, our sine alphas are going to cancel out. We've got sine beta over cosine beta, which simplifies down to tangent beta, so we're good there. So we end up with cotangent alpha minus, plus, that's a plus right here. That's a plus right there. We got that sign. And tangent beta. That's not an answer. The answer is, does it verify? And check mark, yes, it does verify. Now, here are all the equations for cosine and sine. Notice we have both sum and difference formulas for each. You're not going to have to remember these. I'm going to let you have these on the test. I'll probably write them on the board. But there is a quick and easy way to remember this. With cosine, whatever we have here, we have the opposite here. When it's minus, it's a plus. When it's a plus, it's a minus. And they swap. But notice here, these don't swap. You got cosine, cosine, sine, sine. Cosine, cosine, sine, sine. So when the functions don't change, the signs do. Now, the other one is the sines. And notice here, we've got the same signs here and here. But what do we notice about the actual functions themselves in the equation? They do change. We've got sine alpha cosine beta and cosine alpha sine beta. Notice sine alpha here, cosine alpha here. Cosine beta here, sine beta there. So the functions themselves change, but the signs don't. Just a little memory tool if you need to remember them. All right, find the exact value of sine 7 pi over 12 using the fact that 7 pi over 12 equals pi over 3 plus pi over 4. So we're doing a plus. We've got sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Here, functions are different, signs stay the same. Then now all I do is I go back and I plug in my alpha, pi over 3, and my beta, pi over 4, and simplify. So the sine 7 pi over 12 is equal to the sine of pi over 3 plus pi over 4 equals sine of pi over 3 cosine pi over 4 plus cosine pi over 3 sine pi over 4. Alright, so go find all these values. You should know them. If you don't, you need to go back and study your unit circle. So we end up with the sine of pi over 3 is the square root of 3 over 2. The cosine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 4, square root of 2 over 2. Now we're going to do our multiplication. We get the square root of 6 over 4 plus the square root of 2 over 4 and the square root of 6 plus the square root of 2 all over 4 is the exact answer. Now guys, I'm going to go ahead and tell you, you're going to have a lot of these that are going to be very, very much the same. In the same way that we have sines and cosines of all those different angles around the unit circle that are going to be 1/2 or square root of 3 over 2 or square root of 2 over 2. The ones that we're looking at here, 7 pi over 12, is one of those 15-degree angles. So it's going to be very similar to a 15-degree angle that we found just a second ago. You're going to have a lot of combinations of square root of 6 and square root of 2. They could be subtracted, they could be swapped. You could have the square root of 2 minus the square root of 6 over 4. But they're going to look similar to this. You've got to show your work, you've got to show where it comes from. Don't just flip a coin and figure out whether you're going to do plus or minus or whatever. Work the problem out. You've got to show your work. And before you ask, most likely no calculator on the test. Alright, now suppose that sine of alpha is 12 over 13 for a quadrant 2 angle alpha, and sine beta is 3/5 for a quadrant 1 angle beta. Find the exact value of each of the following. So if we're looking for alpha, let's go ahead and figure out what we got here. Sine alpha equals 12 over 13, which is opposite over hypotenuse. So that means our other side, if we draw this out, 12, 13 is going to be 5. You could do Pythagorean's theorem if you need to. 5 squared is 25, 12 squared is 144, 25 plus 144 gives us 169, which gives us the square root of 13, or 13 squared. Alright, so if sine alpha is 12 over 13, then cosine alpha is going to equal 5 over 13. Alright, for my beta, that's for alpha. So draw my triangle for beta. And I'm going to come back and talk about this in just a second because I made a mistake. Let me go ahead and finish beta. So beta, we've got sine is 3 over 5. So sine is opposite over hypotenuse. And remember your Pythagorean triples, that's going to be 4. And here's where my mistake was. Alright, so for sine beta, I'm in quadrant 1. In quadrant 1, I know both sine and cosine. Sine alpha was 3/5. Beta, sorry. And cosine beta is going to equal 4/5. Now, up here I made the mistake. Anybody catch the mistake? Well, it's a quadrant 2 angle. Sine would be positive. Cosine, however, would be negative. So my cosine here is going to be negative 5/13. Because I'm in quadrant 2, my x values would be negative. Therefore, my cosine value, which is based off the x value, would be negative. Even though I've drawn my triangle like that, technically on the unit circle, my triangle would be drawn like this. And there would be your beta right there. Alright, so now, we know what cosine alpha is, found it. So let's go ahead and write it down. Change colors here. So A, cosine alpha, negative 5 over 13. If you don't put the negative, it is wrong. B, cosine beta, 4 over 5. Alright, C, we're looking for cosine alpha plus beta. So all we're going to do is put in all our pieces there. And it's going to be cosine alpha, cosine beta, minus sine alpha, sine beta. And when we plug everything in, cosine alpha was negative 5/13. Cosine beta, 4/5. minus sine alpha, which is 12 over 13, times sine beta, which is 3/5. All right, so do your multiplication. You got negative 20 over 65 minus 36 over 65. So when we do our subtraction there, we're going to get negative 56 over 65. So there is my cosine alpha minus plus beta. All right, and then the last one, sine alpha plus beta. Let me change colors here just so it doesn't. Let me move back over here so I've got enough room. So sine alpha plus beta. And then we write out our equation. So we've got sine alpha cosine beta. Sines stay the same. We got cosine alpha, sine beta. Plug everything in. Sine alpha was 12 over 13. Cosine beta, 4/5. Cosine alpha, negative 5 over 13. Sine beta, 3/5. Alright, so we end up with 48 over 65 plus a negative 15 over 65. 48 minus 15 is going to give us 33. So 33 over 65 is the sine of alpha plus beta. So once you have the equations, it's all just plugging and chugging, finding the values of your trig function, and then plugging everything in and simplifying as much as possible. All right, now we have the sum and difference formulas for sine, for cosine. We also have it for tangent. These come directly from taking tangent and knowing that it's sine over cosine. So if you do sine alpha plus beta divided by cosine alpha plus beta and then do simplifications, you're going to get these two right here. We're not going to work through that or anything, but here are your two equations. Once again, if you need these equations on the test, they will be given, and let me go ahead and tell you, they will be needed on the test, so they will be given. This will be part of the test. You will have to work them out, so there you go. You'll have the equation, you just got to have the knowledge on how to use them. All right, so let's verify the identity that tangent of x minus pi over 4 equals tangent x minus 1 over tangent x plus 1. So we're going to use over here because we've got our identity that we can use. All right, so we've got the tangent of x minus pi over 4. And there's your alpha, and there's your beta. And this equation, let me go ahead and write the equation out. That'll be easier. And the equation is tangent alpha minus tangent beta over 1 minus tangent alpha tangent beta. That's a plus. Alright, so when I go and I plug everything in, tangent of x minus pi over 4, once again, tangent x is just something you can plug in. It's just a variable, just like you plug in pi over 4. So we're going to have tangent of x minus tangent of pi over 4 over 1 plus tangent x times tangent pi over 4. All right, tangent x is just tangent x. tangent of pi over 4. Remember, pi over 4 is where sine and cosine are both the same thing. Anything over itself is going to be 1. We get tangent x minus 1, and 1 plus tangent x times tangent pi over 4. Once again, tangent pi over 4 is 1, so we get tangent x. And if we rearrange the bottom there, we're going to get tan x minus 1 over tangent x plus 1. Now we can rearrange the bottom because they're both positive. We couldn't flip that around and make that 1 minus tangent x on top. Remember, the tangent's positive, the 1's negative. It has to stay the same. If you flip this around, don't know why you would, but if you did, it would be negative 1 plus tangent x. So be careful looking and seeing this get flipped around and think that you can just flip that one around the same way. You can't do it. This has an understood plus out front of it on both of those. And here the 1's negative, and here the 1 is still negative. But anyway, we did verify it, so check. So that's pretty much it. It's just a lot of plugging and chugging in this section, so don't make it more complicated than it is.